All right, guys, welcome to Statistics in the Classroom today. What we're going to talk about today is z-scores. I know, z-scores. And how they relate to confidence intervals. Now, you guys may be thinking, z-scores, z-scores. I remember that term. I remember the word. What was it, though? Well, here's something that might jog your memory. This chart right here. Now, my plan is to have this chart in this Google Classroom post attached to it so that you can access it and take a look at it yourself. But z-scores effectively tell us how far something is away from the mean. Tell us how many standard deviations something is away. And with that, they tell us the percentile that it may fall in as well. So z-scores are important because they lead us to being able to find confidence intervals outside of just the routine 68% confidence interval or 95% confidence interval. Let's say we had a study and we wanted to find a 50% confidence interval. Now, I don't know why you would do that. That's a really small confidence interval, if I'm being honest. But let's say you did, right? So then, here's the idea behind it. I'm going to make up the study first, right? We went and the city is proposing a new tax ordinance, right? And we want to see how many people support it. So they survey 150 people in the city, and we get 23% of them that say they are in support of it. 23% support the measure, right? And we want a 50% confidence interval. So here's what we got to do. What happens whenever we talk about 95% confidence intervals is effectively we place our mean right in the center, and then we say, okay, we're going to grab all this data to this side and to this side, and we're going to kind of play it safe, if you will. Now, 95% confidence interval means 2 standard deviations to either side. Now, technically, that tells us in a 95% confidence interval, we should have 95% of all results, of all possible results to this survey. That would mean between the 2.5 percentile and the 97.5 percentile. Between here is 95% of data. Let's think about again real quick what percentiles mean. A percentile is the amount of data that the statistic you're dealing with is greater than, or the area of which it falls in for how normal it is. You could kind of look at it that way too. Let's say, if we're talking about your height. Well, most people are, I don't know, I'm guessing here around like 5'7" maybe. That might be like 50th percentile. So if you're 5'7", you might be right around that 50th percentile. Okay, that's normal. If you're 6'7", a whole foot taller, you're way taller than most people. So you're up there in that high 90s percentile, right? You're way up top. You're pretty rare. But if you're like 4'11", you might be down here in the low percentile. Also pretty rare, but in a different way. So percentiles work where the middle of it, the 50 percentile, is the normal, the average, the expectation. And being too far away on either side means we're getting closer and closer to what's really unusual, really atypical to see. You don't usually see somebody that's like upper 6 feet tall. You don't usually see somebody that's, in the 4 feet tall range. Both of those are pretty atypical to see on a regular basis. So that puts them on the very fringe edges of our percentiles. Now, for us to be really safe with our 95% confidence interval, we go all the way to these fringe edges. We say, right in the middle is that 50%. That's the number we got from our study. But we are going to extend our standard deviations, extend our sampling errors, as we call it, all the way to these outermost percentiles so that we can, kind of say, well, we got this number, but just to be safe, to go all the way to the outer reaches of what's normal, what's really kind of regular, what's typical, we're going to say it's anywhere from these. Now, sometimes we don't want to be that broad, right? We want to be a little more specific. We want to be a little more confident with what the number we found. So we don't do this 95 percentile. We do a 50 percentile, or whatever other number you want to choose. A 50 percentile would say we're not going to go all the way out there. We're not going to have 95% of all possible data in this range. We're only going to have 50% of data in this range. Well, that 50% of data would mean that we have 25% on this side, 25% on this side. So we would have the 25th percentile to the 75th percentile. Because between those two numbers is 50% of our data. So by changing our confidence interval, we're getting a little closer to the average, but we're also getting a little bit more risky because, I don't know, is it that unusual for someone to be in the bottom 25% or the upper 25%? Probably not that unusual, right? But we still got our central 50 here, and if that's the data you want to go off of, that's the data we can go off of. Now, to do this, to figure out a confidence interval for something like 50%, then what we need to look at is these outer ranges, the 25 and the 75. We want to look at these numbers because we need to know how many standard deviations away from the mean is the 75th percentile, and how many standard deviations away is the 25th percentile. Well, that's where this chart comes in. So let's take a look at the chart here. I know you can't see this on the video, but you'll have the document. And if we're looking for the 25th percentile, that's going to be 0.25, right? Well, I'm seeing down here we have right about 0.25 at negative 0.67. That's what I'm finding, negative 0.67. The z-score of the 25th percentile is negative 0.67. You may already be thinking, I know what that 75th percentile is, but let's see if you're right. If we look over here for the 75th percentile, 0.75, we see it right here at positive 0.67. If you've done these numbers right, these are going to be opposites of each other every time, a positive and a negative, 100% of the time. So that would tell us that to find a 50% confidence interval, we need to only add 0.67 standard deviations to either side. So let's go ahead and do this math here. We have 23% support, so that's going to be our average, right? 23%, 0.23. But let's find our standard deviation. Well, to do that, square root 0.23 times The opposite of that, 0.77, sorry, divided by the number of people that were involved, 150. I'll type that into the calculator here real quick. And we get 0.034, a standard deviation of 0.034. So if we only need to go 0.67 standard deviations outside of that mean, then what we can do is we can figure out what 0.67, or about 2/3 of that standard deviation is. 0.67 times 0.034, we find out that's 0.022. So we add 0.022, and then we're going to subtract 0.022. Well, 0.23 plus 0.022 gets us about 25.2%. And when you subtract 0.022, we get about 20.8%. So this is what the 50% confidence interval would look like. Now, if we would have done this with a 95% confidence interval, we would have been somewhere in the range, and I am estimating just a little bit here, but we would have been in somewhere in the range of 17% up to 29 or 30%. 17 to 30. It's a much bigger range than 20 to 25. But that's because we're more confident that the 17 to 30 is correct. We're more confident that the real, actual number, the true proportion, is in that range, 17 to 30. We're giving ourselves a little bit more room to be wrong, if you will. We're making the safe bet. But if you want to be risky, you want to make the high-risk bet, 50% confidence interval, say, you can go 21 to 25, a much smaller range. But there's still 50% likely you're right. Again, the reason we use 95% is just because we want to make the low-risk statement. We don't want to be wrong, and by including 95% of the potential data in there, usually we're not. We only have a 5% fail rate with a 95% confidence interval. With a 50% confidence interval, we have a 50% fail rate. That's the way really you can think about it. It's a much smaller range. You're more likely, you have you can be technically much more accurate, but you have a 50% fail rate as opposed to a 5% fail rate. We're going to do some actual problems with this, or some more problems with this, and not be so theoretical with it tomorrow. If you have any questions before then, feel free to email me. Otherwise, I'll see you guys then.